We usually picture the moon as a silent, grey desert, peaceful, unchanging, almost boring. But on April 6, 2026, when the Artemis II crew rounded the far side of the moon, they discovered something very different. The lunar surface turned out to be a high-velocity shooting gallery, and the quiet world we expected was actually quite terrifying. The first big change hit them immediately: the noise, or rather, the sudden total silence. Inside the Orion capsule, there's always a constant hum from fans, electronics, and cooling systems. But the moment they crossed the lunar limb and the moon blocked their line of sight to Earth, every S-band radio frequency and every high-speed data link simply stopped. It wasn't a glitch, it was a complete communications blackout that lasted exactly 40 minutes. At that point, the crew was 252,756 miles from home, a new record for human beings. They were effectively the most isolated humans in history. No one on Earth could hear them. No one could talk to them. If anything went wrong, they were completely on their own. The visual environment was even more disorienting. While in the moon's shadow, the crew experienced a solar eclipse that lasted about 54 minutes. Because there's no atmosphere on the moon to scatter light, the moon didn't look like a glowing object in the sky. It looked like a hole in the universe. Commander Reed Wiseman described it as a giant backlit black disk, so dark that it completely obscured both the sun and Earth at the same time. How do you even navigate when your primary landmarks disappear? The psychological impact was powerful. We often hear about the overview effect, where astronauts feel a deep connection to Earth. The Artemis II crew experienced the exact opposite, a total severing. They were moving at thousands of miles per hour into territory where no one could reach them if something went wrong. For those 40 minutes, the four of them were the only living things in a literal void. Suddenly, the scale of the lunar farside felt much more aggressive. It stopped feeling like a moon and started feeling like a massive physical barrier between them and every other person who has ever lived. The crew sat there in the hum of the spacecraft's electronics, simply waiting for the deep space network to pick up their signal again on the other side. But as they would soon discover, the darkness wasn't empty. It was full of kinetic energy that nobody had quite prepared for. And what happened next, captured by the Artemis II cameras, would shock NASA and change how we think about the moon forever. The most jarring part of the flyby happened when the crew actually saw the surface changing right in front of them. It turns out the lunar farside is not the static ancient graveyard we usually see in high-resolution orbital photos. While passing over the dark side, the Artemis II crew reported seeing 6 distinct flashes of light on the surface. These weren't lights from a city or some technical glitch in the windows. According to data from NASA's Meteoroid Environment Office, these were high-velocity kinetic impacts happening in real time. The physics behind it is straightforward, but hard to wrap your head around when you witness it with your own eyes. On Earth, our atmosphere acts as a protective shield. It slows incoming objects down and burns them up through friction. But the moon has essentially zero atmospheric pressure. This means a pebble-sized rock traveling at 30 kilometers per second slams into the ground with its full momentum intact. It doesn't just make a hole, it turns into a tiny momentary star. What the crew was seeing was the direct conversion of kinetic energy into thermal energy and light. When these objects struck the regolith, the heat was so intense that it instantly vaporized both the impactor and a portion of the lunar soil. This created a small, glowing cloud of plasma bright enough to be visible from an altitude of several thousand miles. Astronauts Jeremy Hansen and Reed Wiseman were watching a process that has been shaping the moon for billions of years. Seeing 6 impacts in such a short window of time made it clear that the lunar environment is far more active than the public usually assumes. This discovery immediately raised serious concerns about the vulnerability of the Orion spacecraft itself. The capsule is built to withstand radiation and the extreme heat of re-entry, but it isn't an armored tank. A meteoroid the size of a marble hitting the hull at those speeds would be catastrophic. Being on the far side means the crew was completely exposed to the constant stream of debris that Earth's gravity usually helps deflect, or that our atmosphere normally destroys. These impacts aren't just a threat to the spacecraft, they represent a massive challenge for any future lunar habitation. If the far side is being peppered this frequently, Any long-term structures would need to be buried under several meters of regolith simply to survive the non-stop bombardment. The crew wasn't watching a pretty light show. They were witnessing the primary reason why the moon remains such a hostile place for biology. Even the dust kicked up by these impacts is dangerous. Researchers have studied how secondary ejecta particles can remain in temporary lunar orbit or sandblast anything nearby for long periods. While the crew observed the far side, they were also moving through a debris field that never truly clears. The realization that the ground beneath them was exploding in real time shifted the entire mood inside the cabin. What started as a scientific survey quickly turned into a survival exercise. The moon isn't just a quiet neighbor, it is a world that is actively being reshaped by the violence of the solar system every single hour, and the Artemis II cameras captured every flash in stunning detail, giving NASA an unprecedented look at just how dynamic our closest celestial body really is. Actually, one of the most disorienting parts of the flyby was the way the shadows behaved on the lunar surface. We are used to seeing shadows on Earth that have a bit of blue or grey in them because our atmosphere scatters light into the dark spots. But the moon has no air at all. This means there is no light scattering whatsoever. When Victor Glover looked out the window at the lunar terminator, the sharp line where day meets night, he saw something that didn't look like normal geology. He described the valleys as looking like actual black holes. Without any atmosphere to diffuse the sunlight, a shadow on the moon is a perfect ink-black void. Recorded by the Orion cameras, you can see these sharp, jagged edges where the light simply stops. Glover mentioned that it felt like he was falling straight into the center of the moon. The reason for that feeling is a total breakdown in depth perception. Human eyes rely on atmospheric perspective to judge distances. On Earth, distant mountains look a little hazy or bluish. But on the lunar far side, a mountain peak 50 miles away looks just as sharp and clear as a rock only 5 feet from the capsule. This lack of haze makes the scale of the far side topography feel overwhelming. The crew was passing over the South Pole Aitken Basin, one of the largest and deepest impact structures in the entire solar system. Some of these craters have walls that are several miles high. When those walls cast shadows, they create massive zones of absolute darkness that can swallow entire mountain ranges. This isn't just a visual trick, it is a major technical challenge for any future landing. If your eyes and your sensors cannot tell the difference between a shallow dip and a 1,000-foot drop, because both look like an endless black hole, the descent becomes incredibly dangerous. The crew had to rely heavily on laser altimetry to know where the ground actually was. Glover's observation highlighted how empty the Darkside feels. Even when the sun is hitting the peaks, the rest of the landscape feels like it is missing. It creates a sensory mismatch that the human brain is simply not evolved to handle. This constant nagging feeling that the floor has been pulled out from under you becomes even more intense when you're traveling at 5,000 miles per hour. The optical void starts to feel like it is actively pulling you in. It turns out that the most terrifying thing about the far side isn't the rocks you can see, but the fact that most of the landscape remains essentially invisible until you are almost right on top of it. We always assume that seeing is believing, but on the moon, your eyes are effectively lying to you. The Artemis II cameras captured these dramatic contrasts in stunning clarity, showing a world where light and darkness behave in ways that feel almost alien. The far side isn't just remote, it plays tricks on the mind and challenges every instinct we have for survival in unfamiliar terrain. Navigating a spacecraft around the moon is supposed to be a solved problem in physics, yet the Artemis II telemetry records revealed something unexpected. When Orion reached its perisyntheon, the closest point to the lunar surface, its velocity increased by 0.7 millimeters per second beyond what all the models had predicted. It doesn't sound like much, but for a mission that depends on precise burns to hit a narrow atmospheric entry corridor back on Earth, any unexplained acceleration is a serious concern. This is a recurring puzzle known as the flyby anomaly. Scientists at the University of Bologna and elsewhere have been studying whether it results from some subtle interaction with dark matter, an error in how we calculate Doppler shifts in radio signals, or something else entirely. The fact that it occurred during this crude flight means the far side of the moon still holds variables we don't fully control. Even our best gravitational models are only approximations when put to the ultimate test. But the physics of the orbit wasn't the only surprise hitting the crew with unexpected data. They were flying right through the peak of solar cycle 25, with the sun throwing out high-energy particles at rates not seen in decades. The moon lacks a global magnetic field, so nothing deflects these solar particles. The crew relied on the Hybrid Electronic Radiation Assessor, HERA, to monitor the environment inside the capsule. Radiation levels turned out to be significantly higher than expected. Assigning names to these impact sites is really about more than just map-making. When the crew identified two exceptionally bright features in the South Pole Aitken Basin, they were looking at areas that hadn't been weathered by the solar wind for very long. These are the craters they named Integrity and Carroll. Placing human labels on such a hostile environment is our way of trying to make sense of the void and claim a small piece of the unknown. If you look at the raw images from the Orion's CMOS sensors, the ejecta blankets around these craters are incredibly white. This suggests the material was excavated very recently, in lunar terms within the last few million years, which is essentially yesterday on a geological scale. These fresh scars became some of the only clear landmarks the crew had in a region that is otherwise a repetitive, heavily battered wasteland. The near side of the moon carries names that date back hundreds of years, but the far side remains a blank canvas in many ways. Yet naming a crater doesn't make it any less dangerous. These sites sit in a basin that is over 8 miles deep in places. The sheer verticality of the terrain means any future landing craft will have to navigate around shadows that stretch literally miles long. Those bright rays of freshly exposed lunar soil serve as a clear warning. The crust is being hit frequently enough that the surface never truly settles. The data collected during those few hours of isolation confirmed that our old assumptions about a quiet, dormant moon were wrong. We now have to account for a much more active kinetic environment and a radiation profile that is significantly more intense than anything measured during the Apollo era in the 1960s and 1970s. The moon isn't simply a destination, it has become a critical laboratory for learning how to survive the rest of the solar system. If we can figure out how to shield crews from the constant flashes of light, the deceptive shadows, the gravitational surprises, and the intense radiation seen on the far side, then a crewed trip to Mars starts to look far more realistic.